Welcome, soil conservation and management students from the Royal University of Agriculture. This is our video lecture on session 14, and this is video lecture 14-3 or video lecture 3 on global navigation, satellite systems, and geographic information. I am Dr. Jared D. Williams, a guest professor at visiting professor at RUA and a professor from Brigham Young University, Idaho, in the United States. We talked previously about GNSS and a little bit about how the mathematics and the science works. Now let's talk in this section on the segments, the different actual components that have to work together for a GNSS to work. Okay, so there are three segments that are part of a GNSS. Okay, those three segments, let me get my highlighter here. Those three are what we call the space segment, okay, which will be the satellites, the control segment, which is how we manage these satellites and make sure that they're working correctly, and then the user segment, which is essentially you. Every time you get your smartphone out and you use it to navigate to your friend's house or to your favorite restaurant or wherever you might go, you're the user, okay? And so let's first start off by talking about the control segment. Now the control segment helps to track and monitor, as you can see here, let me change my color, it helps to track and monitor the satellites. It makes sure the satellites are where they're supposed to be, because that's how a GPS system is going to be most accurate. So satellites up in space will actually move a little bit. They'll change where they're supposed to be. We use the term, they will drift. They can drift. Okay. Think of the word drift, think of a boat that's not tied down, right? The boat will actually move in the water even when the engine's not running. It'll drift. And so that's what we're talking about there, is drift. The satellites will move a little bit. And so the control segment, it helps make sure the satellites are in the right position. So right there, I have it listed as satellite positional correction. Okay. They also need to know where the satellites are going to be, or predict where they're going to be. We call that the calendar. Okay, we call it calendar. And so anyway, they help control and manage to make sure that the satellites are being predicted where they will be in the future. Okay, because the satellites are not stationary, they are moving around the Earth in what we call orbit. Okay. The other thing is the satellites have a clock. Now, if you remember from our previous lecture, we talked about how important time was. Okay. In order to calculate your position, to calculate where your location, we have to know what time the radio signal leaves the satellite and what time it arrives at our smartphone or our GPS receiver. Okay, so one of the things that the control segment does is it makes sure the clocks are accurate. Okay? And now the control segment is a bunch of what we call ground antenna. Here's an example of one right here. This is one in the USA. This controls the GPS system used. Okay, and this is actually a picture or a map of the world with different control stations for helping control the GPS system. So this is for the GPS system, but these different locations throughout the world. And by the way, this satellite, this antenna right here, is actually from this location right there. That's where it comes from. Okay, but it's used to help manage and control those satellites and ensure that they are where they're supposed to be. Okay. Next, let's talk about the space segment. The space segment. The space segment refers to the satellites themselves, okay, and where those satellites are. This is an example of the types of satellites that are being used in the U.S. system, in the U.S. GPS system, as it's called. And the GPS standing for Global Positioning System. Okay. And so there are several different types of systems. Now, in the U.S., what we have done is we started off with some earlier satellites, and we've replaced them and we're currently continuing to replace them. So we update them, kind of like your cell phone, right? If you have an Android or an Apple cell phone, once a year they update the phone, right, with a new operating system. Well, it's similar here. As the satellites get old, they have to be replaced, and so they update them with new satellites. Okay? And so these satellites are 20,200 kilometers above the Earth's surface. And there are 4 satellites, okay, 4 satellites in 6 orbital planes. And I will show you how that works on the next slide, how the satellites and what orbital planes are. Okay? So that means there are at least 24 in the U.S. system, but they have reconfigured how it all works, and so now there is actually 27 satellites. Plus there are some extras, some maybe you call them backups. If one fails, then it can be replaced. So there are, in English or in the U.S. we call these, there are 3 alternate satellites which are used to replace those that might stop working. Okay? And then there are some GPS satellites out there that provide additional accuracy with location, and these are called WAS satellites. WAS stands for, and we'll talk about this later, but stands for Wide Area Augmentation System. It's a big word. Don't worry, we'll talk about that later. Okay? And those make up the different satellites that are out there and are being used. Okay? Here earlier I talked about orbital planes and satellites. We talked about the number of satellites in an orbital plane and the number of orbits. Okay? And we said there are approximately 4 satellites per orbital plane, and there are 6 orbital planes. So each of these lines here that you see here, like this one right here, it goes all the way around the globe. That is one orbital plane. And there are 4 satellites in that orbital plane. And there should be a total of 6 total orbital planes here. There's another one going across here. Okay. And so there's 1, there's another one here, 2, 3, 4, and 5, and then the brown one that I mentioned earlier, 6. Okay. The other thing is, because you can see here this little blue dot on the globe represents, say, us, that at any given time, not all of the satellites are going to be visible to you, because some, like right now, we are behind the Earth, and so the satellites on this side aren't going to be visible. So at any given time, only a fraction, only some of the satellites are visible to us. Okay? And you can see here that number changing as the world rotates. As it rotates. Sometimes it's as high as 10 or 11, and sometimes it's as low as 6. Okay? If you remember from our last lecture, the more satellites visible to us, the more accurate we are, because we can select the satellites that give us the best information. Okay? So that is the space segment. The user segment, as mentioned earlier, is you, and how you might use GPS. And in the introduction, we had some videos that you can watch on YouTube that shows how farmers in agriculture use GPS. But we have surveyors, navigation, and many other ways that we use GPS, or GNSS, right? Our global satellite navigation systems. Okay? But the user segment is us, and that's us using it. How do we use GIS? And now, the final slide I have for this presentation is that previously we mentioned that we talk a lot about what's called GPS, or Global Positioning System, which is the U.S. system. Okay, and the U.S. system is one of currently 5 operational systems that are out there. Okay? Other systems that are out there, China, Russia, Europe, and India have all designed systems. So again, as you can see, here's the GPS system, which is designed by the U.S. and has been active probably for the longest period of time and is the most developed system. Then we have the Russian system called GLONASS. And GLONASS is also a fairly old system. It's been around for a while, but not as long as the U.S. system. The Beidou system in China, the Galileo system in Europe, and the NAVIC system in India. Now, the Galileo system in Europe and the NAVIC system in India, as well as the Beidou system in China, are not completely operational yet. Very close. So most of those systems, the Beidou system covers Asia very well and most of the globe. Galileo only really covers Europe, and the NAVIC system in India really only works well in and around India. Okay, there are a few other systems out there that have only regional usage, but the GPS and GLONASS system are worldwide and operational. And I believe the Beidou system may now be fully operational. Okay, that concludes our video lecture number 3 on global navigational satellite systems and geographic information systems, video lecture number 3, where we've talked about the different segments of a GNSS system.